Okay, so now it's recording. So let's just look at this again. This is page, okay, so this is page 341, number 19? Yeah, 341, number 19. Okay, so we're doing it using ratio and proportion first. And there's the information from the question are, how many 650 milligram tablets are needed to make 325 milliliters of a 1% solution? So if we're doing this in steps, we need to know how many grams total we're going to need in this solution. So we have 325 milliliters times 1%, and that's going to give us 3.25 grams. Our second step is to convert grams to milliliters. So 3.25 times 1,000 gives us 3,250 milligrams. And then our third step is to divide by how many milligrams per tablet. So 3,250 divided by 650 milligrams in each tablet gives us 5 tablets. And then if we're doing this using dimensional analysis, we start with how many tablets do we need? 1 tablet is 650 milligrams. A 1% solution is 1 gram over 100 milliliters, but we're going to convert it to milligrams. 1,000 milligrams over 100 milliliters, and we want 325 milliliters total. So if you set it up this way, the milliliters cancel, the milligrams cancel, and you're left with tablets. And when you multiply across the top and the bottom and then divide, you get 5 tablets. Okay, so that's if anybody else tunes in to watch this later. I'll have it on my channel. Okay.
Ms. Lopez, can we do, it's page 382, number 15, and then number 17.
Okay, page 382.
Sorry, I hate to interrupt. Did we answer the second part of number 19's question? As to how much solvent is needed?
Oh, okay. No. Okay, here's the thing with this. It doesn't tell you how much powder volume those 5 tablets take up. Okay, so you're going to pour it in a bottle and QS until you hit the 325 milliliters. And probably your bottle won't have a marking for 325. So you're going to go up to like the 300 milliliter marking, and it'll have a little mark on the bottle at 300 milliliters. And then you can use like a syringe, or you can use a graduated cylinder and measure 25 milliliters more and pour that in. That's what we have to do with some of our solutions, because it's not marked and we don't know how much the powder volume is. So for how much solvent is needed, I don't know what your key says. Does the key tell you? It's going to be a little less than 325 because the tablets are going to take up some space, but we don't know how much space. So I would imagine that it's not more than about 5 milliliters of space, because the tablets, well, those tablets are pretty big. It might even be 10 milliliters. Okay, so the next one is page 382. And did you say number 14?
15, please.
15? Okay. So number 15 says, prepare 50 milliliters of a 1.8% sodium chloride solution. The available sodium chloride solutions are 0.9% and 5%. So how many milliliters of each solution are needed? I'm going to close my window across the way because I'm getting a lot of glare. I'll be right back.
Maribel, are you checking the key?
I went in the back of the book, but it's I have to go into my other computer to find the one she downloaded for us.
Okay, I'm gonna pull it up.
Okay.
Oh, okay, I'll pull it up. Okay, so that was
Thank you.
no problem. Problem, practice problem B.
Where is this glare coming from? Oh, that helps a little bit.
So this next problem is page 382.
Page 382, number 15. Let me go ahead and mark that on here. So it says prepare 50 milliliters of 1.8% solution, sodium chloride. The available solutions are 0.9% and 5%. Okay, so we have where we want 1%, and we need to get it from 2 other percentages. What does this look like?
Oh, is it that tic-tac-toe thing?
Yep. Yeah, exactly. It's an allegation, which we're going to do drawing a tic-tac-toe. Okay, let me find my other pen. Let's see if this one writes. I haven't used a whiteboard in several months, so okay. So which is my target percent?
1.89?
Yeah, 1.8%.
Oh, it's 8, okay.
Yeah. Okay, so it's 1.8, so I'm going to put that in the middle. The glare is so bad, I apologize, you guys. Okay, so what am I putting up in this upper left-hand corner?
5 and 0.9 on the bottom.
And 0.9 on the bottom. Now what do I do?
Subtract each from 1.8?
Diagonally, right?
Yes.
So 1.8 minus 0.9.
0.9.
And 5 minus 1.8.
3.2.
Okay, so then how many total parts do I have?
4.1.
Okay, so now when I'm setting up this math for to figure out the 5%, I'm going to take the 0.9 divided by this total 4.1 times what?
50.
Yeah, that's a little better. Goes here. The 3.2 divided by
4.1 multiplied by 50.
Okay, so this one right here, did you guys get 10.975?
Yes.
Okay, so that's going to be 10.975 milliliters of what?
5%?
Yeah, of 5%. And this one is going to be 39.024 milliliters of what?
0.9%, 0.9%.
Yep. So, you know, on your final, these numbers are going to be reversed. And it might say 10.9 or 11 milliliters of 0.9% and 39 milliliters of 5%, right? So,
Yeah.
and I do that because you guys will encounter that on your national exams as well. They love to do that. You know, if somebody does the math wrong and gets the wrong answer, they'll recognize, oh, hey, it's D, and not realize that they transpose these two things. So be careful with that. Is there another question on that one? How many milliliters, no, of each solution are needed? There we go. Was there another question in this group that you wanted to look at?
I just want to ask for number 17 on the following page of 383, the 1.5 liters, we'll just convert that to 1500 ml then?
Yeah.
It looks like the same way set up. Okay, perfect. So that solves that.
You want to know how many milliliters of each solution. So I would solve it using milliliters to start with.
Got it.
Convert
Okay.
the 1.5 liters to 1500 milliliters. That would be easier for me to do. You can do these problems using ounces. You can do it using milliliters. Or you can do these problems using liters or cups or teaspoons. But for pharmacy and in most nursing, they're going to use milliliters, and milliliters are the same thing as cubic centimeters. So when they say 5 cc's of something, it's 5 milliliters.
Okay, got it.
Can we do number 18? I think it's page 383. It's the one right below 17.
Okay. So page 383, number 18. Okay, a patient needs epinephrine for an acute asthma attack. The physician orders 100 milliliters of epinephrine, 4%. So we want 100 milliliters of 4%. The available epinephrine is 1 to 10 and 1 to 100. So we have 1 to 10 and we have 1 to 100. Okay, so you have one strength that you need and you have 2 strengths that you have available. Oh, I know what that is. That's my other computer. There we go. Okay, so you know what I'm going to do with these, don't you? Are we going to leave them as a ratio?
No.
Yeah. Convert them to percent.
Yes, we're going to convert them to percent. So I'm going to do 1 over 10 times 100 is what?
That's 10%?
Yep. And 1 over 100 times 100 is 1%, right? Because remember, the number on the left is your grams and the number on the right is your total milliliters. Grams, milliliters. So you put the left over the right and then multiply it by 100. So I have 10% and 1%, and I want to end up with 4%, right? Okay, so since it's closer to the 10% than it is to the 100%, wait a minute. Okay, yeah. Okay, it's closer to the 1% than it is to the 10% because we want 4%. We don't want 40. So just get my chair up closer. Okay, so in doing this, we know we're probably going to need more of the 1%. So let's do this and figure out if that's what we need. So we draw our tic-tac-toe, and what goes in the middle?
4%.
And what goes up here?
1%,
And what goes down here?
10%.
Okay, so normally I tell you to put the bigger number on top, but it doesn't matter. So let's do it this way. As long as you know when you go across here, your answer here is going to be the 1%, and the answer down below is going to be the 10%, okay? So what goes here?
6,
6, and what goes down here?
3,
3, because we're subtracting diagonally. 10 minus 4 is 6, 4 minus 1 is 3. And what's my total number of parts?
9.
9. So 6/9 times how many milliliters?
100.
100 is going to give me a certain number of milliliters of, which one again?
1%.
1%.
1%. And down here, I'm going to have 3/9 times 100 is going to give me a certain number of milliliters of, which one?
10%.
10%. So now you can do the math. I like doing the setup first because now I'm not going to accidentally say that this is my 10% and this is my 1%, right?
Yes. So it's 66.66 and then 33.33.
Yep. So we'll call it 67 and 33. And does that get us 100 milliliters?
Yes.
Okay. Was there another question on that one?
No.
No. Just how many milliliters of each solution? You guys remember how to check it, right?
Mm. That's that long process. I never did.
Okay. So what are we combining? We're combining 67 milliliters of 1% plus 33 milliliters of 10%. And I'm going to end up with 100 milliliters of some percent. And I hope it's going to end up being 4, right? Okay, so 67 times 1 is 67. 33 times 10 is 330. 67 plus 330 is going to be 397, right? And remember,
Yes.
I rounded these. Divided by 100.
3.97.
3.97, is that pretty darn close to 4%?
Yes.
Yes, so there you go. So that is correct. So that's your check. Now, I'm not asking you to check it. I'm not going to quiz you or test you on that check process. It's just so you can know how to check and see if you got the correct answer.
Just seems so much easier when you do it.
Well, I think because I actually do it in real life. And so like I can actually visualize myself taking 67 milliliters of 1% and pouring it in a bottle, and 33 milliliters of 10% and pouring it in a bottle, and then how much active ingredient is in each one. So I think just because I've done it for so long, you know, and the math I've done since at least 2001. So
Oh, wow. Yeah.
yeah, 19 years of this math, I better be good at it. And you guys know, sometimes I still have to go, wait a minute, what do I do again? If you don't do it every day, it's easy to forget. So
It's true. Okay, we do number 9 on page 369.
yes.
Sorry, I don't know if Monica had anything on Maribel.
Okay.
I try to look for that second portion on the pre-test for Maribel, but for some reason on my phone, I can't tell. Where's number 19? I don't think it has the practice problems for chapter 14.
That's in the key. I don't know if I can access the key while I'm in this meeting. Okay. So you said page 369. Which one?
Yes, number 9, please.
369, number 9. Okay.
Number 9.
8 ounces of betadine solution, 2%, and we have 10%, right? Okay, let's try it this way. I have until the middle of January to do a better desk setup than what I have. Keep telling myself I need to work on it now, and then I don't. So, okay. Position, okay, so page 369, number 9. Do this way. Eight ounces of betadine solution, 2%. And the available stock solution is 10%. Okay, so we have 10%. All right, now we don't have a high and a low, and we want to get one that's in the middle. Instead, we have a high, and we want to dilute it to a low. So this is a dilution problem. So what do we use for dilution problems? Do we do the tic-tac-toe?
No.
No. Okay, so you can actually, you can do the tic-tac-toe. Your bottom number is going to be 0. Just so you know.
I like the tic-tac-toe.
How do we do the tic-tac-toe with this one?
Yes, can we do it? I like the tic-tac-toe. Makes it easier to solve.
Okay, so we're going to use solvent. Okay, so we're going to use our stock solution, and we want to end up with 2%. Okay, so the 2 goes where?
In the middle?
In the middle. And then our stock solution is 10%. Where should I put it?
On top and 0 on the bottom?
Yeah. So this gives you a ratio. 10 minus 2 is 8. 2 minus 0 is 2. And that's going to be 2/10 times. What am I going to do with this 8 ounces?
Convert it to milliliters. It's 240.
8 ounces is 240. Yep. 8 times 30 is 240. Okay. Now this one is now going to be 8/10 times 240. And that's going to give me so many milliliters of 0%. What the heck does that mean? 0% what?
Yeah.
What is 0%? It's your solvent. Okay, so that could be water. It could be, what else would you mix betadine solution? And you could mix it in normal saline. I cut my finger. I was trying to use scissors like a box cutter, and the blade flipped over and I sliced my finger. It was not pretty, and it didn't want to stop bleeding. So I went over to urgent care, and they made me soak my finger in a betadine with normal saline mixture before they glued it shut. So that was interesting. I thought I was going to have actual stitches, and I didn't, which was kind of sad because I wanted to come home and show my kids, look, I got stitches. But no, that didn't happen. Instead, it was like, look, I got glue. That's not. Okay, so 2/10 times 240.
48?
I have to do the math. Times 40. Yes, 48. And 8 divided by 10 times 240.
I got 16.
Okay, but 48 and 16 won't equal 240.
So what did I do wrong? Okay, so let's see here, times 240. Oh, 192.
Yeah.
That makes sense.
Okay, now add these two together.
And that's 240.
Yep, so that equals 240. So very good. Okay, now the other way you can do this, okay, so here's how we do this with a 0% there. So you know you can use your tic-tac-toe for these dilution problems as well. But then, you know, And it tells you how much solvent if you do the tic-tac-toe one. Okay, but now if you're going to use that dilution formula, you have your stock volume times stock strength equals, what are they calling the final volume again? I'm telling you, I keep wanting to go I and F instead of S and something else. Desired. Okay, so your desired volume times your desired strength. So we know we want 8 ounces, which we're calling 240 milliliters because we convert everything to milliliters if possible. Where does the 240 go? Which one of these is the 240?
The desired volume.
And your desired strength is?
2%.
And your stock volume is what we don't know, right? But what's the stock strength?
10%.
Yeah. Okay, so we got 48 milliliters before for our 10%, right? And then to figure out your diluent, you're going to take the 240 minus 48, and you should get 192 milliliters of diluent. So like I said, that diluent could be water, and they would probably use sterile water, or it could be normal saline. They could dissolve this in normal saline or dilute it with normal saline. Yeah. Okay, so you come out with the same answer either way, right? Okay. I was trying to figure out how to hang this on here, but it seems like it's too far away from my computer for you to really see it. So I gave up on that idea. But I'm going to have a better setup next spring. And then in January, like 2 weeks after class starts, they're going to tell me I can come in and do class in the classroom again, right after I get everything set up. That's okay, though. I'll be happy to go back. And that would be a wonderful thing, but it's probably not going to happen, at least not until later in the semester, probably. So I'm trying to think.
So next fall, I think.
I'm afraid so. I mean, we always hope for the best and then you plan for the worst. So just in case, the worst would be doing the whole semester here from my living room. And, you know, we can do it if we have to. I'll have a better setup. I might move back into the office like I was last semester. But we'll see. And then, you know, you hope for the best. Maybe we can get back in the classroom and I'll have, you know, my students measuring this stuff out. And that's always better because I think you learn a lot hands-on, even more so sometimes than if you just look at the theory of it. Don't you think?
Yes, that's what I miss the most.
Yeah. I mean, you can inject an orange, but it's not the same thing as have a person sitting there and they're flinching, you know? Ah, oh, that hurts. Your orange is not going to complain at all, right? Okay. No, I'm not having you inject in a math class, okay? That was just a hypothetical. I'm not qualified to teach anyone to inject. I do know how. I've given my dogs shots, but they don't complain too much either. Usually because my son is feeding them something while I'm doing it. All right. What else do you want to see?
Can we do chapter 15, page 400, number 17?
Yes, let me find it. Okay, so it gives you a recipe to make a certain amount of bromhexene hydrochloride syrup. Oh, it even has a footnote. I wonder what that footnote means.
I'm sorry, what page was this?
Page 400.
400.
I wonder where the footnote is. It gives you a, oh, it's probably in the back where they have recipes. Okay.
That's the post-test.
Page 400. Number 17. Okay, so how much of the following ingredients are needed to make 120 milliliters? So it gives you bromhexene hydrochloride, and it tells you 80 milligrams, and glycerin, 20 mLs, sodium benzoate, 240 milligrams, and then fruit flavor, QS, tartaric acid, is 340 milligrams, sorbitol, 45 milliliters, sodium carboxymethylcellulose, that's your suspending agent, so we're going to call it cellulose, just so I don't have to write that whole thing out, 200 milligrams, and purified water. And you're going to QS to 100 milliliters. Okay. And then it gives you a place to put all of your changed recipe. Okay, so here's the original recipe. You have all of these things, and this makes 100 milliliters. So now it wants to know how to make 120 milliliters. So you just want 20% more, don't you? So 100 times 1.2 is 120, right? So the way that you figure that out is you take what you want and divide it by what you have. You have a recipe for 100, you want 120. 120 divided by 100 is 1.2. Okay, so your want over have is 1.2. Now all of these, starting at the top, you're going to multiply by 1.2. And your fruit flavoring, we'll have to figure out how much that is. And okay, so QS is quantity sufficient. What it means here for fruit flavoring is how much fruit flavoring you want. So I would get like within a few milliliters of the 120, maybe 110, and add a few milliliters of fruit flavoring and see if that's a good taste, and then QS the rest of it to 120. Okay, so when we multiply all this by 1.2, we get 80 times 1.2.
96.
96 milliliters of the bromhexidine hydrochloride. And the glycerin is going to be 20 times 1.2.
24.
240 times 1.2.
288.
Milligrams. The fruit flavoring we don't have to worry about. Tartaric acid, 340 times 1.2.
408.
And the sorbitol It's 70% sorbitol, and we just have to realize that that is the percentage of sorbitol in the sorbitol solution. And when we use a certain amount of it, it's not going to be 70% anymore. But the question isn't asking about what percentage of sorbitol. Okay, so we don't have to do any math with this 70%. It's just the name of it. So 45 times 1.2. And the 200 times 1.2. And then our QS is going to be 120. So when we add all of this together, we can add our milliliters together and then subtract that from 120 and we'll know how much liquid to add. But the thing is, you don't know how much room these milligrams are taking up. You know, like how much space is this 288 milligrams of sodium benzoate taking up? What's the powder volume? Because that's probably a powder. So until you figure that powder volume, and this is why it says QS, because you're going to mix these things together without this water, and then you're going to pour it in a bottle and add water till you get to the 120 milliliter line. Okay, so that's the QS. And again, it's because powders have different densities and they take up different amounts of space. So you could have a gram of something that has the same density as water and it would take up 1 milliliter, or 1 milliliter of water weighs 1 gram. But on these things, we don't know how much space 288 milligrams takes up, or how much space 408 milligrams or 240 milligrams of these different substances take up. So that's why you mix it with some of the liquid, pour it in a bottle, and then QS, you know, add the rest of the liquid and then QS to 120. Okay. Is that making sense?
Yes.
It's fun to compound things like this, and I don't get to do enough of this type of compounding. We usually make compounds with a certain number of tablets and so much Aura Sweet and Aura Plus. Sometimes we'll have sorbitol. Sometimes we'll have Flava Sweet, which is another brand of sweetener. It's like, it's just a sweet syrup to put these things in. And sometimes we'll use glycerin, because glycerin tends to make some tablets dissolve better. But, you know, I don't do a whole lot of weighing out powders of this type. We do make zinc. And what's the other one? We weigh out a powder of something else that we weigh out and we put in the bottle, and then we QS with usually cherry syrup we use for that one. I can't remember which powder it is though. Haven't made that one in a while. Okay, any questions on this type of thing? You're taking a recipe.
On that same question, I'm sorry. On number 17, there's like on the next page, 401, it says, what is the percentage of the sorbitol in the final preparation?
Didn't I tell you that there's not going to ask about the sorbitol? And then what do? The next question is sorbitol, right?
Ah, got it. Okay.
Okay, no, that was me. I should have known it would ask about the sorbitol because I said they wouldn't. Okay, so if we have 54 milliliters of 70%, how much active ingredient is that? So 54 times 0.7, because that's 70% converted to a decimal. Okay, if I can get this cap off my pen. I always have to laugh at myself because the minute I say we're not going to do something, there it shows up. Okay, so we have 54 milliliters of 70%, 54 times 0.7.
37.8.
Yep. 37.8, and we'll call this grams of active ingredient because I don't know what sorbitol you know, what it actually, is it a milliliters, is it grams? I don't know. We'll call it grams, and we're going to put it over our total amount, 120 grams over milliliters times what?
100.
Equals?
Let's see here, divided by 120 times 100, 31.5.
Yep. So it ends up being 31.5% in your final preparation. So do you see what we did? We had 54, where'd it go? 54 milliliters of sorbitol. 70% of that is active ingredient. So 54 times 0.7. So I turned that 70% into a decimal, and this tells me I have 37.8 either grams or milliliters of active sorbitol. Divide it by my total amount of solution times 100 grams over milliliters, or active over total times 100, gives us a 31.5%. Okay, is that making sense? And it did ask how much sorbitol, Kim.
And then Professor,
It didn't, there it was.
could we do number 2 and 3 on page 415? That's chapter 16.
Yeah.
Ten hours times 16.
Page 415, number 2 and 3. Let's do number 2 first. What is the infusion rate of 500 milliliters of NS, which is normal saline, administered over 10 hours? Okay. So infusion rate, we're looking for milliliters per hour, right?
Mm-hmm.
Okay.
Oh, okay.
We don't know how many drops because it doesn't say anything about the administration set. So when we're talking about an infusion rate, the only thing we know is we could figure out milliliters per hour, or we could change the hours to minutes and we could figure out milliliters per minute, right? So
Yeah.
we have 500 milliliters over 10 hours is equal to what, 50 milliliters per hour?
Okay.
It says rates can also be presented as an amount of medication delivered per hour or per minute. So if it's 50 milliliters per hour, how many milliliters per minute would that be? Oops. Okay. I could say 50 milliliters over 60 minutes, which we already know 50 milliliters per hour. So 50 divided by 60 would be 0.833 repeating milliliters per minute, right? But I really think it's looking for this one. And if you look on your key, that's probably what it says.
Okay.
And
Because
then
it's asking it's over 10 hours.
yeah.
Got it. Okay. I don't know why I want to convert the 10 hours to 600 minutes and then divide the 500 by 600, which gives you, okay, per minute. Okay. Oh, got it. Doing extra.
Okay. And number 3 on that same page, how many milliliters of fluid will a patient receive in 3 hours? So I want to know milliliters in 3 hours if the infusion rate is 125, so at 125 milliliters per hour, okay? So we want to know how much fluid. That's going to be my milliliters, right? So if it's 125 milliliters in 1 hour times 3 hours.
375, okay. 25.
Now, if you want to do this one using ratio and proportion, you certainly can. You're going to have 125 milliliters in 1 hour, and that's going to equal X milliliters in 3 hours. Okay, and then you need to cross multiply, and you get X times 1 is X, 125 times 3 is 375. And it has to be milliliters because that's what you're solving for. Okay.
Thank you.
Okay, look at number 4. Number 4 says, how much fluid will a patient receive in 10 hours if the order is for 50 milliliters per hour? Well, didn't we just solve number 2 and get 50 milliliters per hour?
Yes.
So how many milliliters are they going to get in 10 hours? Just looking at this.
Milliliters. Oh, so it just times by 10, so you get the opposite, 500 ml.
Yep, because see, question number 2 says if a patient receives 500 milliliters over 10 hours, it's 50. And question number 4 says if it's 50 milliliters an hour, how much are they going to get in 10 hours? So they just took number 2 and, you know, basically asked you the same question backwards. Okay. I've been posting the recorded portion of the lecture to YouTube. Have you guys, have you been looking at that at all? Has it been helpful? I'm thinking that more people are looking at those things on YouTube who aren't able to come to the actual meetings, right?
Right.
Yes, sometimes I go back. Sorry, go ahead, Maribel.
For the most part, when I'm doing the quiz, I go to the book.
Okay.
Yeah, the book helps me with the quizzes.
Good. Yeah, because I had one of the videos, and I think it was on chapter 14 or 15. It was one of the percentage chapters, had like 25 views last time I looked, which was good because that means that students who aren't able to come are still actually, you know, getting something out of lecture. So I feel like it's worth it, even though sometimes it takes me a long time to get everything converted so it'll post on YouTube, because I have to convert the Zoom meeting first so it will save on my computer, and then I have to post it to YouTube, which I don't know what they call it. I think they call it uploading, but it takes a while for that to happen too. So I always have to play around with it for at least an hour just to get it to post. So if I look at it and it has 0 views, then I'm like, oh, why did I bother? So it's nice to see that they all have a few views at least. It's like, okay, if even one person looks at it, then it's worth me, you know, playing around with it and getting it to post. So, okay.
Sometimes I go back too and look at some of the questions that were a little hard to understand the first time when I was in lecture.
Oh, okay.
The second time it'll just like stick. I don't have to think about it again.
Good. It's kind of like practice makes perfect, and you look at it a few times. do you guys, I know you're not in class together, but I don't know if some of you guys maybe know each other and talk to each other and maybe do homework together or something. I mean, that seems to happen when we're in class. I met a girl named Carmen in my calculus class, and honestly, she's the only reason I got through calculus, because we would meet, our class was at 9, so we would meet at 8 o'clock in the cafeteria, and we would get their really bad coffee, and we would sit there and go over all of the questions from the last class. And, you know, that's really, like I said, it's one of the only ways I got through calculus. You know, I don't know, if you guys don't really know each other, then it's harder to do that. And plus, you know, we're all told now to stay home, so we can't exactly meet at the cafeteria. And that's kind of a shame, because I think you meet a lot of interesting people when you are in class, people that you wouldn't have met otherwise. I never would have met Carmen outside of class because, you know, her husband was involved in Riverside politics, and, you know, not somebody I would have really spent a lot of time with or got to meet. But, you know, I met her in class, so that was cool. And we kept in touch for a while. I'd probably recognize her if I saw her again. That was like in like 98 or 99, so a long time ago.
Yeah. I have my professor for anatomy, Miss Lopez, and she forced us, in a sense, to do a discussion board and get to know people, to get together. And I learned really quickly after the first chapter that I'm not going to be able to get through this just online without like a group study session. So I have like 4 girls that I studied with throughout the week for that class. And we do it through Zoom, so virtually, and it's working. It's really nice.
Good. You know, I tried to do discussions at first, and I'm just so much better in person leading a discussion. It's really hard for me to post discussions, and then what I'm supposed to do is like go back every day and check on our discussions and then give people points for posting to the discussion. And you know, that's one of my failings. I'm not good at that, and I don't really have the time to do it, you know, with being gone. By the time I drive to work 8 hours and come home, that's 10.5 hours I'm away from home. So, because it's an hour there and back, and then I have a half-hour lunch. So, you know, it wasn't happening, so I gave up on that. But, you know, that's kind of a shame, because I think it would have helped you guys maybe a little more to be able to branch off on your own a little bit more and that kind of thing. But I do like I remember Monica, hi Monica, from one of my other classes. And so like I have a picture when I see Monica's name, you know, I know who she is. And, you know, I haven't met all of the students that way or had them in other classes to really remember what they're like. But you know, I like that you guys talk to each other sometimes and stuff. So I think that helps. Okay, any other questions on the study guide? Was the study guide helpful?
Yes.
Yeah.
Okay, good. Good.
I really want to work on, like, from chapter 14 on. It seems like there's a lot of steps for those. That's why I'm trying to get as quick as I can.
I sometimes think that most of our books, and I have to say with pharmacy technicians, since it's a vocational class, a lot of our books start with basic math. And sometimes they'll spend way too much time on the first basic math. And if you're working on like a bachelor's degree, you can assume that someone has already had algebra and trigonometry and calculus, and now they're, you know, doing this other thing. But we can't assume that. So we almost have to start with basic math, but I really think we spend sometimes too much time on it. This book really doesn't get into the first part of pharmacy, which is conversions, until like chapter 5. So the first, you know, the first few weeks, I think, don't always help that much. You know what I mean? And I wish there was some way I could skip straight to chapter 7 or 8. But I can't. So, you know, there you go. But like you were saying, chapter 14 and on is where we really get into some of the things that you need more practice on sometimes, you know. And I know I do sometimes too, so I get it. Although
Yeah, I went through this.
Go
I
ahead.
went through the study guide. Sorry, I went through the study guide up to chapter 13, and then when I got into 14, I decided to take a break. It got harder.
This is at this point, I would be handing out candy in class because our brain uses, this is my excuse. Our brain exclusively uses glucose for fuel. So it's a good excuse to eat chocolate while you're doing homework. That's my excuse. I oftentimes can think better when I have a little bit of sugar in my system too. So, you know, I get it. Okay, are there any questions in particular that you want to look at while we're here? I have to tell you guys, I'm going to miss having you in my Zoom meetings because there's been like 7 people that will show up fairly often. And, you know, even though I don't even really know what some of you guys look like, I'm still going to miss talking to you every week. So thank you for showing up.
No problem. Trust me, I wouldn't be able to get by it without watching how you do your work. Yeah.
True. True. We can do number 3 on page 417. That's chapter 16.
Okay, page 417. Number 3. Okay, so a physician orders 1 liter of 3% dextrose to be administered over 6 hours. That's kind of a low amount of dextrose, but that's okay. Over 6 hours. Okay, so $417, number 3, and it is 1 liter of 3% over how long again? 6 hours. Okay. If the complete bag of fluids is administered, how many grams of dextrose will the patient receive? Okay, so again, let's go back to the 3%. What does 3% mean? 3 grams in what?
Okay. In 1 liter? So that's, no?
3% means per 100, right? So it's 3 grams in 100 milliliters, but they don't have 100 milliliters. They have how many milliliters?
1,000?
1,000. So they're going to get 10 times that amount, aren't they? So instead of 3 grams, they're going to get 3,000 divided by 100, which is 30 grams of dextrose. Okay, so they're getting a liter, not 100 milliliters. They're getting 10 times that. So if they're getting if they were to get 3 grams in 100 milliliters, they're getting 30 grams in 1,000 milliliters. Or you can say 1,000 times 3% equals, and on your calculator, you do the same thing, 1,000 times 3, and you hit your percent key, and you get 30. And that's going to be 30 grams. Now, if you hit enter after that, for some reason, it takes your answer to 30,000. So depending on what type of calculator you have, you might hit 1,000 times 3, hit the percent key, and you'll get 30 grams without hitting equals. But if you hit equals after that or enter, you'll get a huge number. And I don't know why my calculator does that. And some of them do and some of them don't. Usually about a half of the students in my class will have a calculator that if you hit the percent, you'll get the right answer. But then if you hit equals, you'll get a huge answer. So just be careful with that. That's another way to do it. And then the next question is, if the fluids ran for 5 hours only and the patient is discharged, how many grams of dextrose did the patient receive? Okay, so now instead of 6 hours, they're only getting it for 5 hours. So 5 out of 6 hours, yes?
Yes.
Times, what's the total amount?
30?
30 grams.
That's 25.
Yeah. So if you just do on your calculator 5 divided by 6 times 30, you get this number with lots of nines. And then that's going to round to 25 grams.
Okay.
Okay, does that make sense?
Yes, thank you.
Okay. Because instead of running for 6 hours, it only ran for 5 hours. So they're getting 5/6 of it. Okay. Now you could figure out how many milliliters per hour, multiply it by 5 hours to get the milliliters, and then multiply that by 3%. And you can do it that way too. Either way, you should get 25 grams.
And it could be the last one on page 422, number 3.
Of course, page 422, number 3. Okay, so number 3 says, a physician orders 250 milliliters of D5NS. That's a combination of normal saline plus 5% dextrose to be administered over 16 hours to keep a vein open. That's just so it doesn't form a blood clot. The drop factor is 60 drops per milliliter. How many drops per minute should be administered? Okay, so this is one of those drop per minute questions, and then it'll say how many milliliters would be administered per hour. It's easier for me to figure out how many milliliters will be administered per hour. How do we figure that one out? Let's go to question 2 first.
Okay. Per hour, 16 hours. So it's like 250 divided by 16?
Yeah. What do you guys get?
15. At 15.625?
Yep. So it's approximately what, 16 milliliters per hour if you round the 6 up? Okay.
Yes.
So that's the answer to that one. And then the first question was how many drops per minute should be administered? Okay, so we want drops per minute. So do you remember how to get that rate in drops per minute? You need to figure out the volume times the drop factor over time will give you the rate, right? Okay.
Yeah. Okay.
So your volume is how much?
The 250?
Times 60 drops per milliliter. And my time is 16 hours times 60 minutes per hour, right? Hours are going to cancel and that'll give you minutes. Okay, so working on the top first, 250 milliliters times 60
15,000.
Yep. Yep. And 16 hours times 60 minutes.
960 minutes.
Yep. So 15,000 divided by 960.
Go on, 15, same answer. 60, 15, 625. Yeah.
Okay, so now the reason you have the same answer, okay, is, and this is going to round to 16 drops per minute also, is because you have 60 minutes in an hour and you have 60 drops in a milliliter. So since you have, you know, the 60s involved as a conversion factor, there's a really high chance you're going to get the same answer.
Mm.
I know, isn't that crazy?
Yes.
16 drops per minute and 16 milliliters per hour. Okay. So if you're doing this drops per minute question and you want to use dimensional analysis to do that, and we want to end up with drops per minute, okay, then you can set this up. You want to know drops first. So it's going to be 60 drops per milliliter, 250 milliliters over 16 hours. And you want to convert the 1 hour to 60 minutes. Okay, so your hours cancel, your milliliters cancel, and you have drops on top and minutes on the bottom. But look at your 60s. 60 drops, 60 minutes. The 60s are also going to cancel. So you have 250 divided by 16. And you get the same 15.625, which rounds to 16 drops per minute. Okay, so this is how you can do this using dimensional analysis. So because there's 60 minutes in an hour and 60 drops in a milliliter, your milliliters per hour is going to be the exact same answer as your drops per minute.
Okay.
Yeah, I'm trying to get the glare off the board. Can you see that a little better there? Okay,
yes.
So that's doing this problem using dimensional analysis. Okay, so again, I don't care how you do the problem. What I care about is, does it work for you? Whatever way you choose, does it help you get the answer? And that's the most important thing. I'm not here to teach you algebra per se. I'm not here to teach you just dimensional analysis. If ratio and proportion works for you, use it. You know, our brains all work slightly differently, and even though certain parts of the brain perform certain functions at the neuron level itself, everybody's neurons are slightly different. It's like we all have a forest, but we all have different pathways through the trees, right?
Yes.
Right.
Okay, so don't, this is what drives me crazy about teaching math to children. When they get into basic math, some instructors will insist that kids do one thing and some instructors will insist that kids do something else. And then the math that they were teaching kids, and I don't remember what they're calling it now, where they're making them estimate first. It's a good thing to learn to estimate, and I do a lot of estimating, you know, in my brain when I'm doing any, you know, any kind of math, like, do I have enough money to buy this blouse and this shirt? Or do I have enough money to put gas in my car and get groceries? I do a lot of estimating, and a lot of people do it and don't realize that they're doing it. But when you make a child do it and they don't understand that, I think you have to know the mechanics of math first before you can do your estimation. I really do. So I don't necessarily think that it's such a good thing the way that they're teaching. Some schools are teaching math to kids right now, because I see my coworkers with their kids, and they're actually bringing their kids' homework into work and saying, I don't know how they're doing this. And like, you know, they passed all of this math, but they can't do the math that their kids are doing, especially when they're trying to teach them at home. It's kind of frustrating. I really feel for all of you guys who have kids doing Zoom classes at home right now, because we all know in actuality, you're doing a lot of the teaching, you're doing a lot of their homework and that kind of thing, or at least making sure that they know how. So
It's true. I'm learning algebra all over again.
right? Yeah, and having homeschooled my oldest kid, I get that, you know, because we were literally just handed packets and the books and said, here, go home and do it. And he would go in and meet with a teacher once a week, but he wasn't getting a lot of lessons. A lot of it was turning in homework. So that's when my husband said later in my 40s, when I thought, I wonder if I could teach pharmacy techs at these schools. My husband goes, well, you already taught Max. Well, yeah, that's right. Okay, maybe I could give it a try. And, you know, still teaching 16 years later.
Well, you're very good at teaching math, I have to say.
Well, thank you. I hope I'm able to get it across, because I'm just passionate about it making sense. And, you know, you have to be able to do it, and you have to be able to take it and apply it to your career, you know, because you guys are going into healthcare, or some of you are already in healthcare, and you know how important it is to do the math correctly so you don't give someone an overdose or give them too little and it's not effective. Because if the doctors think that you administered the correct dose and nothing happens, they're going to increase that dose, you know, and that won't be good. So it's, you know, it's crucial. It's critical for healthcare to be able to do proper math. But like I said, doesn't matter how you do the math. Do you get the correct answer? That's the most important thing. And that's why I show you guys more than one way, because there's always more than one way, almost always, to do any math problem. So a lot of times I'll throw dimensional analysis out there and some people will go, I don't get that. I don't understand what all these different, you know, fractions are all about. And then we do ratio and proportion and they totally get it. And vice versa. You know, somebody doesn't like ratio and proportion. And I see it with my, I did a review class at UCR and I had a lot of biochem majors in there and they already had bachelor's degrees. So they already have more education than me and I'm teaching them math. But, you know, for them, the dimensional analysis is what they've been doing this whole time. So it made sense to them. So, but, you know, they hadn't worked in pharmacy. So that's what I was bringing to the table was my pharmacy experience. So I got over that whole, oh no, they know more than I do pretty quickly. So that was good. And you know, it's funny, one of my students from my first UCR class in 2012 is now a pharmacist at our hospital. And I didn't even recognize him when I first met him. And they're like, oh, it's this our new pharmacist, you know? And I'm like, hi, nice to meet you. And he goes, you look so familiar. And I said, really? I don't think I've worked with you before. And then he said, did you teach a class at UCR? And I was like, oh my gosh, really? And then I had to come home and look up his name in my old books and there it was. So, wow, that was amazing to me because, you know, he was one of those biochem majors that was going into pharmacy. So pretty cool. I've enjoyed that part. It's like a yay, somebody you know, took my class and now look where they're at. By no means did I have anything to do with it, but I'm still proud of them anyway. So pretty cool. Okay, any more problems you guys want to look at?
I'm good. I think I just have to go back and re-review the last couple of chapters again.
Yeah.
And again.
Okay. And Maribel?
I think, well, you know what? Let's do something we haven't done yet. Let's shoot for page 389, number 1.
Okay.
Okay.
Calculate the amount of grams of each required to make 30 grams of the following. Oh, it's a number of parts problem. I like these. Okay. Like, oh, it's an allegation. Ooh, it's a number of parts. Oh, well. At least I like what I do, right?
Yeah, I love it.
389, number 1. Okay, so it says calculate the amount of grams of each required to make 30 grams of the following. To make 30 grams. And it says drug B, you need 1 part. Look, they don't even bother to come up with a drug. It's just any drug, drug B. And then lanolin. Lanolin, where does lanolin come from, you guys? There's a lanolin cream that they give new mothers if they're going to breastfeed. They call it nipple cream.
I'm not sure where
It comes from an animal.
Oh, I thought it was an oil.
The cow, the sheep.
It's an oil. It comes from
I'm a cow, sheep.
one of those farm animals. Yeah, lanolin is sheep oil or sheep fat. And then petrolatum, which is basically Vaseline.
Petroleum.
So they're making a medicated Vaseline is what this is. And it's going to be 8 parts of that, of the petrolatum. So what are we going to do? How many parts total, right?
10.
Yes, 10.
And how many parts do we have?
3.
1, 2,
Well, there's 3 different items. But we've got 8 parts lanolin, 8 parts petrolatum, 1 part lanolin, and 1 part drug B.
like all together, 10.
Yeah, so altogether 10. So drug B is probably something like neomycin or bacitracin if it's going to be an antibacterial ointment that you're making. But it could be something else. Could be an anti-inflammatory drug like, what's the one that they just came out with? Diclofenac, which is, I can't think of the brand name of it, but it's similar to ibuprofen. It brings down swelling. So they could be doing something like this. So again, we don't know what drug B is, but there it is. So you have 10 parts total, right? So for drug B, 1 out of those 10 parts times what?
$30 grams?
Yeah, times 30. Right? So if it's going to be 3 grams of drug B, your math for the lanolin is going to be exactly the same, right? And then what do you do for the petrolatum?
8 divided by 10 times 30?
Yep.
It should be 24.
That's what I got.
Okay.
Now, how do you know if you're correct? 3
So
plus
add
3
them up,
plus 24?
maybe 30?
24, 25, 26, 27, 28, 29, 30. Look, we can count on our fingers and do important math.
30 grams.
30 grams, yes?
Yes.
Okay. Okay, so that's if, yeah, this is like a basic recipe. You can make this recipe make any amount. We could do 300 grams. We could do, 14 ounces, and you're going to do you're going to do the same thing. And when you get to this is going to be your total amount of however much it is. Okay. So you'll see a lot of times in these big drug compounding books, it'll say, you know, it's going to be one part of this, one part of that, one part, you know, 14 parts of something else. And then you'll do the exact same math to figure out whatever your total is, because that's just, you know, how many parts of that. So it was similar to when we got out the tequila, and we were talking about how many shots are in this particular drink, right?
Yes.
It's more fun
I
in the
like that part.
room, I have to say. Okay.
And you're still gonna hold a class or kind of like review hour next Thursday, Ms. Lopez?
Yeah, I can have one more next Thursday, and then your final will be the following day. So I think that's a good idea. I think you guys had a good idea there, that we'll do the final on Friday. So I like that.
Yes, thank you for that, because then that gives me a little bit more time to review and go over this and have maybe additional questions.
Yeah. So, you know, keep going over the review, and then, you know, let me know about your other questions. And you guys have my phone number, so you can text me, right? If you have any concerns or anything before then.
Yeah.
Okay. It's really hard to do math on text messaging, though, just so you know. I usually send pictures of things. I'll do it on paper, take a picture, and send you the picture. But yeah, I can't do it at work, so that's the only problem. I can only do that when I come home from work. I was driving with my husband to see his mom a couple of years ago. It was like a weekend, and we were going out to Redondo Beach to see his mom. And I get a text message, and I get a napkin from the side of my door because he was driving. And I start writing on it with a pen and taking a picture of it. And he looks at me and he goes, "Math question?" And I said, "Yeah, okay." He just keeps driving. So yeah, I'm kind of used to doing math whenever, but I can't take a lot of time out of work to do it, because I have some people that complain that work with me. So it's like they can be playing on their phone, but I can't do math. Whatever. Anyway, okay, any other questions today?
No, thank you.
No, I think we're good. We covered quite a bit. Like I said, next week for sure, I'll if I have more questions, I will go over.
Okay, so in between you guys working and homeschooling your children, I want you to finish the review, okay?
Yes.
Yes, for sure.
Okay, you're doing a great job, you guys. I really appreciate you showing up to these meetings. So I'll see you next week.
Okay, have a good week, everyone. Stay safe. Have a blessed week.
You too. Bye.
Wear your mask when you have to leave the house, you know.
Yes.
All right, bye.
Bye.
Bye.